going to continue looking at properties of integer exponents. We're going to look right now at power of a power, and then we'll look at power of a product. Alright, let's first look at what power of a power says. When raising a base with a power to another power, multiply the exponent. Remember, power is the same thing as an exponent, because you could say something to the second power, and that means it has an exponent of 2. So what we're looking at is a base number, and it's going to have an exponent, and then it's going to be raised to another exponent. And when that happens, you're going to multiply the exponents together. Alright, let's look at a few examples. The first example is 8 to the 4th power, and we're cubing that. So we've got this base of 8, and we've got it to the 4th power, and then to a second power, which is the 3. What this actually means is we have 8 to the 4th power 3 different times. And that means in all we have 12 as our exponent, because it's going to be 8 to the 12th power. And the rule says all you have to do is multiply your exponents together, and that's going to give you the new simplified exponent, 8 to the 12th power. Same thing with the next one. We've got w to the 4th power squared. What that really means is we've got two groups of w to the 4th power. And that would mean we have w to the 8th power. And our rule says all you have to do is multiply your exponents when you have power of another power. And that will give you your new exponent. I'm not going to show all of the work for this next one because it would be very time consuming. But what this really means is we've got 5 groups of k to the 7th power. So if you could imagine, we've got 7 k's here, k times k times k times k, and so on. 7 here, another 7, 7, 7, and 7. My power of a power rule says all you have to do is multiply your exponents together, and that means it's k to the 35th power. I would end up having k being multiplied by itself 35 times. Our next one, we have the opposite of 3 groups of x squared. The reason I said the opposite of is because we're dealing with a negative exponent right there. So we've got 2 x's here, 2 x's here, 2 x's here. What that ends up being is x times 2 to the negative, or times 2 to the, x and then 2 times negative 3. X squared to the negative 3rd power. X squared to the negative 3rd power is the same thing as x, and then 2 times negative 3 is negative 6. We're going to see this more when we get to our negative exponent property, but you can leave this like this, or you can write it using the reciprocal, 1 over x to the 6th power. Number 5, 3 squared to the 5th power. That would be 5 groups of 3 squared. That ends up being 3 to the 10th power. And then the last two, we're having to do the work 3 times. It's 2 cubed, squared, and cubed again. We're multiplying 3 times 2 times 3 here. 3 times 2 is 6, and 6 times 3 is 18. If you worked all of this out, you would have, first of all, 2 groups of 2 cubed, 2 groups of 2 cubed. And then you're going to have 3 of those. So that gets repeated 2 more times to have a total of 3 of these. And if you count out all of those 2's, 3, 6, 9, 12, 15, 18, you have 18 of them. The same thing here, 5 cubed to the third power and then to the fourth power. Multiply all of those exponents out. 3 times 3 is 9, and 9 times 4 is 36. 5 to the 36th power is what that one would be. Now we're going to look at power of a product. This is not the same thing as product of powers. Product of powers we already looked at, and that was where you were multiplying the same bases and you added your exponents. With power of a product, it's actually similar to power of a power. You're raising a product with exponents to another power. So this is going to deal with multiplying your exponents together, just like we saw with power of a power. When you do product of powers, you add your exponents. So let's see how this is different from that. This is going to have, first of all, it's going to have parentheses. And if you look back at product of powers, the only parentheses we had was to make sure that we didn't lose our negatives, but all you have is a base times that same base. It's not a power of a power. So it's a base times that same base, and you add your exponents together. This is going to be dealing with a power raised to another power. But it's called a power of a product because we're dealing with a coefficient and a variable, sometimes multiple variables. So the way that this works is you're going to multiply the exponents for each part of your product, the 4's exponent and the p's exponent, to whatever the power is outside of the parentheses. So this part's going to be 4 to the first power, and 1 times 4 is 4. It ends up being 4 to the fourth power. P cubed to the fourth power. 3 times 4 is 12. So it's 4 to the fourth power, p to the 12th power. If you wanted to simplify this down by actually working out 4 to the fourth power, you could. For now, I'm just going to leave it alone. And then we've got 6x to the 5th power, y to the 11th. All of this to the 4th power. 4 groups of this. Now, let's start off with each part of our product, break it down. 6 does have an exponent. It's 6 to the first power. 1 times 4 is 4, so this would be 6 to the fourth power. We would end up with 4 6's. And then 4 groups of x to the 5th power. 5 times 4 is 20. And then 4 groups of y to the 11th power is going to be y to the 44th power. The next one, negative 5 w squared y to the 8th power, all of this cubed. So we need 3 groups of all of this. Negative 5 to the first power, 1 times 3 is 3. So we're going to have negative 5 cubed. Remember, the parentheses just help you not lose your negative. It makes it stand out. W squared cubed, 2 times 3 is 6. Y to the 8th cubed, 8 times 3 is 24. The next one, 2 to the first power, m to the 5th, n to the 11th, all of this to the 6th power. 1 times 6 is 6, 2 to the 6th, 5 times 6 is 30, m to the 30, 11 times 6 is 66, n to the 66th power. Now, be careful with fractions. You definitely want parentheses when you do this one, because you want to make sure that you know that you're doing the entire 1/4 squared. What do I mean by that? Well, if you did 1/4 squared like this, it would look like you're only doing the 1 squared and you're not also squaring the 4. You have to do 1/4 times 1/4, which would be the same thing as 1/16. If you worked this out and just squared the 1, you'd end up with 1/4 again. So make sure that you put fractions in parentheses. That way you're squaring the entire fraction. And then 5 times 2 is 10. 3 times 2 is 6. And again, on any of these parts with just the number, you can simplify those. Maybe I want to go ahead and simplify this and make it 1/16 W to the 10th Z to the 6th. Number 6, same thing. You want to make sure that you put parentheses around your 3/5. That way you know you're squaring the entire 3/5. If I just did 3/5 squared like that, it looks like I'm only squaring the 3, which would give me 9/5. 9/5 is not accurate. It's not the same thing as what we'll get when we simplify. 6 times 2 is 12, and 9 times 2 is 18. If I did go ahead and do 3/5 times 3/5, that would give me 9/25. A to the 12th power, B to the 18th. Now this one right here is going to require a little bit extra work. 3/10 squared, and then P to the 8th, and 5/10 cubed, P to the 6th. Now this is still not completely in simplest form. The reason I say that is because you can combine your P values together, and you can combine your coefficients together. So I'm going to move these together. 3/10 squared and 5/10 cubed. And then if I have P to the 8th times P to the 6th, there's what product of powers looks like. Remember, product of powers, look back at it. Product of powers is when you're multiplying the same bases, you're going to add your exponents. So if I have, let's go back to that. If I have P to the 8th here, 8 P's, and then I have 6 more, I end up with 14 of them, because I can add those together. And then if I actually were to work this out, I'd get 900 here, and I would get 5 times 5 times 5, 125 thousandths here. And if I were to work that out, eventually, I would get a very, very, very small decimal number. 1,125 hundred thousandths, P to the 14th power. Tenths, hundredths, thousandths, 10 thousandths, 100 thousandths, 1,125 hundred thousandths times P to the 14th power. So that's a little bit of a look on power of a power and power of a product.